meeting is now being recorded.
All right, Rashmi, all yours.
Good morning, everyone. Ming and I will be sharing with you today a project showcase of the systems engineering efforts and Minnesota Statewide Regional ITS Architecture update. Today we will be covering an introduction to ITS and the ITS architecture, systems engineering efforts in Minnesota, as well as the Minnesota Statewide ITS Architecture. Then we'll get into some of the systems engineering practices, as well as the implementation process and tools, and follow it up with next steps and some enhancements that we have ongoing. We think of ITS and benefits. Intelligent transportation systems includes the electronics, communications, or information processing used singly or in combination to improve the efficiency or safety of a surface transportation system. ITS facilitates that stakeholder communications, collaboration, coordination, and data sharing. It's cost-effective and has typical measures of effectiveness when it comes to capacity and throughput, safety, time savings due to delays, cost savings, energy and environment, and overall customer satisfaction by minimizing driver frustration. We think of what is an ITS architecture. An ITS architecture facilitates stakeholder communication and system integration. Think of it as like a city plan, and that city plan sets building codes and plans common services such as roads and water. An ITS architecture does the same for the ITS technology as far as it describes that region, participating agencies and stakeholders, how those agencies and modes and systems interact and operate, and it develops a framework for planning, defining, and integrating ITS. Why do we need an ITS architecture? We do need to ensure compliance with federal requirements, 23 CFR 940, and that allows that eligibility for federal funds. Within that 23 CFR 940, there's systems engineering analysis and ITS architecture requirements. We also choose to foster that integration of ITS deployment by helping with the planning and procurement of connected and interoperable systems. That promotes proper considerations of technology, interoperability, and future expansion, as well as enhancing that financial effectiveness. Next, I'm going to Ming will take over and talk about the ITS systems engineering efforts in Minnesota.
Thank you, Rashmi. And this is Ming-Shiun Lee with AECOM. And so I'm going to utilize the next two slides to just briefly introduce what are the ITS systems engineering efforts that's been going on in the state of Minnesota. So Minnesota has been a pioneer state in the U.S. for applying innovative technologies and strategies to improve safety, mobility, efficiency, and productivity of the transportation system. ITS deployment in Minnesota started initially with a focus on combating congestion problems in Twin Cities, Minneapolis, and St. Paul metropolitan area. The application of ITS technologies expanded over time to smaller urban and rural areas in the past 3 to 4 decades. Over time, with multiple systems deployed along with increased need for data sharing, integration, and to facilitate interoperability and seamless transportation operations and data exchange. And those become very necessary. To foster integration of the ITS deployment, the Minnesota Department of Transportation, MnDOT, under the guidance of Federal Highway Administration, Minnesota Division, developed a programmatic process to guide and improve the implementation of regionally integrated and interoperable ITS systems in Minnesota. The systems engineering guidance for ITS was developed based on the USDOT policy and guidance issued by the 23 CFR 940, which is titled for Intelligent Transportation System Architecture and Standard, and in short, we call it Rule 940. So in the past few years, MnDOT has followed the systems engineering principle and developed a series of technical reference system tools to support the use of systems engineering for ITS projects. And this programmatic system engineering analysis has been conducted for several commonly deployed ITS technologies. Documentation from those analyses, including concept operations and requirements, provides helpful guidance for the planning, design, implementation, integration, extension, operations, and maintenance of those systems. And one thing I want to note is those commonly deployed systems account for roughly 90% of ITS implementation and expansion in Minnesota. Continues to expand the systems engineering analysis effort to additional ITS applications such as dynamic message signs, closed circuit surveillance television, vehicle detection system, brand meters, and communication network. Another important ITS systems engineering effort, as Rashmi alluded, is the ITS architecture. MnDOT and transportation stakeholders in Minnesota are using the ITS architecture as a starting point. The Minnesota Statewide ITS Architecture was initially created in 1997, and it has gone through multiple iterations for the updates. The most recent update will be completed by the end of this year. Another effort is the development of the Highway Project Development Process, or HPDP, and specifically for ITS projects. The HPDP for ITS provides specific directions on the use of the output from the programmatic systems engineering process and the Minnesota Statewide ITS Architecture. It also provides guidance on assessing gaps in systems engineering requirements and steps to perform additional analyses to be in compliance with Rule 940. MnDOT worked closely with their internal staff, partner agencies, and the Federal Highway Division Office in Minnesota to develop and implement a process that provides detailed and step-by-step guidance to MnDOT staff and local agencies. And this ITS implementation process consists of several elements, including an overarching regulatory guidance and a step-by-step procedural guide with tools and references. And we will talk about those more about this implementation process later. And this process was implemented in 2019, and several enhancements has been made since then. And so this slide, on the slide you can see on the right-hand side is the systems engineering V diagram for ITS. The development of the ITS architecture, as you can see circled in the blue color, is the first starting point of the ITS systems engineering process. And as Rashmi alluded, the ITS architecture helps identify user needs and set the stage for system feasibility investigation and alternative analysis, and allow you to follow the left side of the V, go down to further define and help defining the high-level concept operations and system requirements. And more about the ITS statewide, the Minnesota Statewide ITS Architecture. This architecture is a singular architecture covering the entire state of Minnesota, including the 8 urbanized metropolitan areas and the rest of the state. It was developed using the National ITS Architecture Framework, or now we call it a National Architecture Reference for Cooperative and Intelligent Transportation, also known as ARCIT. This architecture includes a comprehensive list of user needs as well as needs for further technology research and development. And they also include a brief operational concept to identify needs and describe what's the current condition, ITS capabilities, as well as potential ITS solutions and who's involved and what stakeholders' roles in terms of implementing and operating those solutions. And one important part of the architecture is the implementation plan. An ITS implementation plan was developed to strategically frame out a path for future ITS implementation and expansion. This ITS implementation plan serves as a starting point for planning and systems engineering analysis for projects that were identified and prioritized in the plan. The architecture helps ensure that MnDOT derives the maximum value and functionality while establishing interoperability from its investment in ITS infrastructure. And more about the ITS implementation plan. And the ITS implementation plan, also called the ITS implementation volume of the architecture. It includes 150 ITS concepts and initiatives. And those project concepts cover all potential ITS solutions in various ITS functional and service areas. Project and system components, high-level functionality, and system and user interfaces are defined for each project concept within the volume. The information established a foundation for developing a concept operation and systems requirements. We put a screenshot of one of the project concept right up on the screen, kind of loaded what kind of information is presented for each individual project. And based on this analysis, we identified several different projects, and Rashmi is going to talk about kind of showcasing a project that were identified through the architecture and then follow through the systems engineering process and to plan, design, and procure the centralized traffic control software system. Rashmi?
Thanks, Ming. So I'm telling you about a successful story on a project. We had the centralized traffic signal control software procurement. This illustration is prior to the upgrade that we had for the centralized traffic signal control software, otherwise also known as CTSDF. We identified needs, our project needs here, where MnDOT Metro District utilized Siemens I2 Central Traffic Signal Control software. And the I2 software was no longer going to be supported. So Metro District planned to continue to expand that central system and migrate their signals off of ARIES. That was really the primary driver behind MnDOT's procurement of a new central traffic signal control software system. So we identified some project goals here, and that started us off with performing a systems engineering analysis to identify those needs and features of what a new centralized traffic signal control software should be. That included fostering that integration of the deployment with regional ITS systems and components while we were complying with the federal regulations, and then enhancing MnDOT's financial effectiveness while taking proper consideration of those systems' interoperability as well as the future expansion compatibility. It was really important for us to work cooperatively with agency partners to achieve the greater safety, mobility, and efficiency on the signalized arterial system. Then we wanted to make sure that we were developing procurement specifications that met the operating needs of MnDOT and its agency partners. And those agency partners were also were all the MnDOT districts as well as cities and counties. So here we have MnDOT deployed a centralized traffic signal control software where that accomplished the operational concepts and met the stakeholders' needs. Here this diagram shows the primary centralized traffic signal control software, where that was the software solution together with the associated databases that users throughout the state access from their desktop computer, laptop computer, and mobile devices to manage the traffic signal controllers configured in the system. Then we have the backup centralized traffic signal control software, where that is a mirror image of the software system to the primary, and that utilizes situations where if the primary centralized traffic signal control software may not be operational, either because the software is not operational or maybe a lack of connectivity or power to the primary centralized traffic signal control software, then this backup would periodically synchronize with the primary such that all the databases, login accounts, data, etc., are all available to the operators should they need to use the backup system. And then we also have our system interconnects. So these interconnections that are needed to enable operators to access the centralized traffic signal control software, that enables them to communicate with the traffic signal controllers that are configured in the system. So the systems engineering analysis required the 23 CFR 940, which allows that ITS projects such as this one to move forward with proper consideration of interoperability and future expansion. This entails like the development of our CONOPS, our system requirements, detailed design, procurement specifications, plans for system testing, verification, acceptance, and validation plans. So with the concept of operations, we developed to present the fundamental needs of MnDOT and what they had for the centralized traffic signal control software, as well as the operational concepts that illustrate how the system will be used to control traffic signals that are operated by the department. So there were several stakeholders affected by the centralized traffic signal control software procurement. And because the procurement was being led by MnDOT's Metro District, their traffic office, they managed the signal operations in the Twin Cities metro area. So they were the primary stakeholders for this effort. So what we did was we built on that operational concept. So this table here describes the suggested roles and responsibilities for the stakeholders who will operate and maintain the centralized traffic signal control software. And there are roles and responsibilities described based on those that were already in place on the current control software that we had, but then, and as well as the traffic operations environment. But the intent here is that you want to use this table. It's to maintain that consistency and familiarity among all the stakeholders is really important. And you want to use that to ultimately ensure that the operations of the centralized traffic signal control software is efficient. So then that gets us into our needs, where you think of the needs and the concept of operations serve as that basis for system requirements that will be used to develop specifications for the procurement process. So in this case, we met with the stakeholders and operators to discuss the project, and we identified 17 needs to be addressed. We then mapped those needs to the operational concept and requirements. These needs were described and numbered for identification and traceability purposes. So the concept of operations describes that operational concept in relation to the 18 areas of functionality that will be provided from the centralized traffic signal control software, and each piece of the concept was further described in terms of how it will address the stakeholder needs, and then the operational concept was intended to help each stakeholder group see how their needs have been interpreted and how the system is expected to address their needs. And then we finally had the requirements I established as far as they were used to develop detailed specifications for the procurement documents. And when we think of the procurement documents, the systems requirements documents builds on those operational concepts and needs to present a series of requirements associated with the centralized traffic signal control software that MnDOT wished to procure. So these procurement documents were developed based on the systems engineering analysis and the specific administrative requirements that were prescribed by MnDOT. So these key components of the procurement documents included the request for proposal, references, requirements documents, cost proposal. We had lots of lessons learned in this effort, and I'd love to share those with you, like meeting with the project team and stakeholder input at the key decision points were needed to obtain valuable information and to keep that whole process moving. Having that full compatibility with the signal controller features, thinking of that proprietary management information-based data, that may be needed by the operating agency, but then you also want to think of the NTCIP compatibility isn't always enough. So because the full compatibility with the controllers is desirable, the number of potential systems available are limited. So unless an agency is willing to swap out existing controllers, that was kind of something that you really need to think about there. And so reaching out to the potential vendors early in the process was very useful to determine what requirements were really realistic. Another key point here was checking with your legal and administrative staff early on what's allowed during your evaluation and procurement. Key. Then also the procurements. Involving multiple agencies can be difficult because of the increased complexity caused by just even like you think of the interagency agreements, you think of the competing needs, the schedules and funding, and any differences in ranking of the evaluation criteria. We have even more lessons learned here. We found that building off previous systems engineering documents and specifications whenever possible is really important. Collectively, you can use those agencies' procurement documents as a resource. That saved us a lot of significant effort on this project, and then you're able to tailor accordingly to your needs. Another thing that we found a huge lesson learned was that maintaining focus on our goals. It's important for us to kind of find it key that, the adaptive signal control requirements and a new signal controller procurement were discussed, but excluded and pursued separately to maintain the focus on the centralized traffic signal control software features. So MnDOT desired this procurement process to really set the stage for further use of the same centralized traffic signal control software throughout all MnDOT districts. This greatly enhanced the overall centralized traffic signal control software product, but it also offered some other enhancements with our stakeholder team, is really developing an overall understanding to support the regional ITS integration, especially in this case, the regional signal operations. And we had counties, Dakota and Hennepin County followed, as well as City of Bloomington. Also, this offered another awareness opportunity for us and enhancements that were identified for the development of the MnDOT ITS implementation process. And I'm going to hand this over to Ming to share with you about the ITS implementation process. Ming?
Thank you, Rashmi. And so we talked multiple times about this Minnesota MnDOT ITS implementation process. This process is developed by MnDOT, and the purpose is to promote the use of systems engineering to facilitate conformity with the FHWA regulation, the Rule 940 National ITS Architecture and Standards. The Minnesota implementation process builds upon the statewide ITS architecture and systems engineering principles. It features a programmatic process to guide the ITS project development process, from planning, design, to implementation, operations, and maintenance. To facilitate the use of the implementation process, MnDOT also developed various tools and references to guide ITS project managers to properly plan, develop, integrate, and implement ITS projects. So the purpose of the process, and as I mentioned earlier, to promote consistent use of systems engineering and also to ensure in compliance with the federal rule. It also helps to foster regional ITS plan development coordination and integration. And also one of the purposes is to promote proper consideration of system interoperability and ongoing operations and management needs and future expansion and integration. All these contribute to better investment decision as well as resource utilization. The key components of the implementation process include the HPDP, and which provides specific direction on the use of the systems engineering process, and also utilizing the Minnesota ITS Architecture as a starting point. And furthermore, it provides guidance on assessing gaps in system engineering requirements and performing additional analysis. And it also provides specific guidance on how to utilize ITS architecture to perform consistent check to ensure the project is developed inconsistent with the architecture and is following the federal regulation and meeting the systems engineering requirements. Another key component is the project scoping worksheet, and those provide assistance in project planning and development. And those plan sheets, those scoping worksheets allow proper consideration and identification of resources needed to perform adequate systems engineering analysis for ITS projects. And this reduces the potential of a project manager overlooking ITS components in their projects. In addition, it promotes the awareness of the ITS systems engineering requirements, stimulate collaboration among the ITS functional groups, and assist in properly scoping and resource allocation for ITS projects to ensure adequate systems engineering analysis is performed. And various tools were also created to facilitate the implementation of the process. And those tools including a list of useful resources and references, a quick reference guide that provides step-by-step instructions to walk users through the process, a decision tree to guide identification of system engineering analysis requirements and needs, ITS systems engineering checklist to ensure conformity with the federal rule, and also a project website to house all resources, guidance, and references. The screenshot shows the web page, and later on we will provide the link to the MnDOT systems engineering website where you can find all the relevant resources, documents, guidance, as well as some tools. So among the tools that have been developed, one of the key tools is the decision tree. And so we're going to utilize the next two slides to talk about the decision tree and how that can help with implementing this process. On the right-hand side of your screen, that's kind of a smaller diagram. That's kind of the whole view of the decision tree with some tables down underneath. That table is actually the project classification chart. And there's a link to that decision tree document on the slide as well. And so basically the decision tree guides the users through identifying which project category their project belongs to. And based on that the project classification chart, a user can easily identify which project class the project he's working on is belong to, and then follow the decision tree to determine what type of systems engineering requirements have to be met, and then what are the actions they have to take in order to reach that goal. And this is the project classification chart, and it's color coded. And also in the previous slide, the decision tree, you can see the same color coding. So the color coding is one of the enhancements that was made in the past 2 years, and try to help people to visualize, follow the decision path, and to get a better understanding on the requirements. And so this project classification chart, based on the type of systems engineering effort that has done in the past, and classify different type of project into different categories. And this is still a kind of work in progress, evolving process, I should say, that as MnDOT and the stakeholders continue to add in more and carry out more systems engineering effort, the list is going to be to change over time, and that would further enhance the usability of this process. And Rashmi is going to talk about the next steps and how we envision any further enhancement on this process will be.
Thanks, Ming. Yes, so as Ming mentioned, as far as the next steps and enhancements, and as in relation to the decision tree, MnDOT, as we work through and try to identify what are those systems that we're using so commonly, or just, what is a big percentage of what we're deploying out there and so forth. And we've identified with our Regional Traffic Management Center as far as 5 different systems that we want to make sure that we have our systems engineering analysis fully performed, as well as offering that connected and automated vehicle readiness component in there. So that includes, we have an ongoing effort right now where the DMS, CCTV, vehicle detection, communications, which is the fiber wireless, and ramp meters will be completed this spring. And due to those enhancements, or due to that systems engineering analysis that will be completed, that will be really offered in such a way that, well, besides the ramp meters portion, everything else would be a statewide resource for folks. So the locals would be able to utilize that. And then what we would do is, due to that systems engineering analysis being completed, we will shift our decision tree so that that will reflect that programmatic process that's in those enhancements that are involved in that decision tree and some of the other resource documents that we offer for systems engineering. We also have connected automated vehicle projects. We have a connected corridor project ongoing, and we continually work on enhancements of the systems engineering ITS implementation process. Our business needs are always changing, and we need to make sure that we're meeting those with these resource documents as well. So we're always trying to stay in tune with that so that we can make sure that we're not creating any gaps with this ITS implementation process. So here I have some links and resources. The first link here is our systems engineering webpage, and that offers resources, not only the checklist, but also offers our HPDP, our FHWA implementation memo. It offers CONOPS and requirements and links to that, as well as some resources that are directly related to this ITS implementation effort, where you could find the decision tree and some guidance, regarding how to work through your ITS implementation in relation to the systems engineering and the ITS architecture for compliance with 23 CFR 940. And then this next link is the Minnesota Statewide Regional ITS Architecture webpage. And that will be, right now, that link brings you to the 2014 ITS Architecture, but shortly, early part of January, we'll be publishing the 2018 ITS Architecture, and that will still be found at this link. We want to keep that consistency there for folks to be able to get that, access those links. And next, I guess thank you. I just want to know if anybody has any questions.
All guests have been unmuted.
All right, so everyone is unmuted. You may want to mute yourself back if you don't have questions, but if you have questions, feel free to ask. Well, maybe I should mute back off, and if you have a question, you can unmute yourself.
All guests have been muted.
If you have a question, please unmute yourself.
All guests have been unmuted.
Well, I guess I'm going to just share some things. So as we, here we
go. Yeah, my bad.
We'll see, yeah, how that goes, or Brexit or no Brexit.
So I think there's a
Hey,
question.
looks like this. I'm back on. This is Oliver. I have a question. Can you hear me?
Yeah.
Hello?
There's background. Someone needs to get on mute.
Some Brexit discussions. I have a question. So there's a couple of pilot projects already on the way of, self-driving cars. Any of those are actually in compliance with, with those ITS architectures?
Right now, MnDOT is working on connected and automated vehicles, and we have to pass legislation for self-driving cars. But we have our architecture written up in such a way that it's a livable document, and we are staying tuned with including that. But right now, legislation doesn't allow for complete self-driving cars. Ming, would you like to add on to that?
Yeah, MnDOT is in the process of, they did initial pilot test on the autonomous shuttle bus earlier this year, and they are moving forward with testing some of the technology on different types of vehicles. And so we kind of, the architecture does include those projects and the concept, but we kind of follow the US DOT's National ITS Architecture Framework and in reflecting those kind of the technologies in there. And obviously the technology is still evolving and evolving at a very rapid pace. And I foresee that there is going to be more updates and changes that need to be reflected in the architecture.
All right, so Jesse Glaser, who was a presenter of Systems Engineering back in June, has a question on the chat box. Have you had any interest in using the Agile Systems Engineering processes?
Of course we have an interest. Could you explain a little bit further? I mean, and Ming, do you have anything to add? I'd like to get a little bit more understanding of, I have an interest. I don't know what more we can, I'd like to hear a little bit more of what he's talking about or what he had in mind.
Yeah, I'm not sure if Jesse is on the phone.
Maybe I'll respond.
Let me try to answer this question.
Okay.
I think it's, a lot of systems engineering effort that MnDOT has conducted over the years are more focusing on the the term I use, traditional ITS systems and components. And agile systems engineering process and will certainly benefit from, especially for connected vehicle and automated vehicle type of application. And I do believe that as kind of I see other agencies as well as the U.S. DOT is starting looking into adapting the agile systems engineering into the connected vehicle area. And so I think that although we have not started on that as far as the implementation process and the architecture effort, but individual projects that's coming up, especially related to connected vehicle area, we'll certainly start looking into that.
I think we're going to try to get Jesse on the phone. Is that what you're going to work on, Hokie?
Yeah, I just unmuted Jesse, I guess. Jesse,
Okay.
say something?
Something.
Hi, Jesse. Thank you.
Hi, thanks. I just wasn't coming through. Well, I think you largely answered the question, but we have a couple of projects that are developing software applications, just purely software. And they are, one in particular is saying that because of the uncertainty about the user needs and how the human interface will work, things like that, they feel agile development, kind of an iterative process where they do a lot of preliminary, like rapid prototyping used to be preliminary implementations, have the users use it, review it, and then make major changes if necessary. I guess I'd make that's a quick thumbnail sketch of what we see Agile to be, as opposed to the V process, which is largely deterministic at the beginning.
Yes.
So have you encountered any of those projects? Have any of you?
Not yet, but I kind of see that we are going to be faced with that very, very soon. And we would like to learn more about that.
Okay, thank you. What we've seen is that it's really applicable for software development, especially for apps and websites that will be used by a wide range of people, and you don't know what their needs are, what their limitations are, et cetera, until you actually put it out there. Very similar to the way our apps on smartphones work with frequent updates as they're emerging.
Okay, good.
That's how I look at that. It's a capability to connected vehicle area, because the connected vehicle itself kind of changes game plan for a lot of things, and because the technology allows you to provide direct information interface with the driver, the human part, and then there are a lot of data security vulnerability issue that need to be addressed. And so I think this process will definitely provide some value to that.
Let me add that that Federal Highway Administration has prepared a report on the use of Agile within the 940 regulation. I can send you a link to that.
I
have
love
to look
that
it up.
link.
I can't do it immediately, but I can send it to you afterwards. It is not guidance. It is not policy. It's simply a report that says, here's how some people are using it, and here's some possible ways of using Agile in conjunction with the V process.
Oh, okay, great, yes.
Yeah, I'll do that after the session finishes here.
Yes, I'd appreciate that. Thank you.
Thank you. That's it.
So that's also what Jesse was presenting back in June, and his webinar is up on our YouTube channel.
Yes.
Yes, INCOSE was very, very instrumental in helping U.S. DOT to recognize the need to to begin using Agile and to provide guidance for at least information, not necessarily guidance or regulations yet, but information on how it can be used and how it relates to the V process, because many people think it replaces the entire V process, which it does not do, with the possible exception of small standalone apps that don't need integration, aren't part of anything bigger, et cetera. So
Okay.
it's a big issue for us here.
Yes. Absolutely.
Thank you. That's it. I'll go back on
Have
mute.
you worked a lot with that then?
We're just starting now to work on it on one project that's getting underway that is a software-only project. It's just the very beginning, so we're still doing the system engineering management plan to figure out how exactly it will be used, what procedures, how it will connect to the V process.
Okay.
So we're new, we're learning.
Okay.
Yeah. All right, so we also have another question in the chat box. Oliver, he asked, are you enforcing ITS standards? Example, vehicle OBEs, remote vehicle, from the vehicle OB to the remote vehicle OB is vehicle location and motion. If Oliver, if you're online, if you're on the phone, you can unmute yourself and talk to Rashmi and Ming directly. If you're not, then I think Rashmi and Ming, you can answer the question, or you want more information from Oliver?
I'm here.
Yes. Okay.
Can you hear
All
me?
right. Yes. Yeah. You know more. You know Global Meet more than I do. So.
Yeah. So basically, there is a connected vehicle reference implementation architecture, which was rolled into the new ITS architecture.
Yeah.
And so and then if you look into the physical architecture, you'll not only see all the wayside equipment, but you also see the actual vehicles, right?
Mm-hmm.
And they communicate with each other via dynamic short-range communication, for example. And I just used one example, and so the standard I'm referring to is actually an SAE standard, Society of Automotive Engineers. Mm-hmm. And I worked on a project before where people were just shrugging their shoulders when I was talking about ITS. So the question is, if you truly want to achieve interoperability between all the moving parts, you need to enforce the standards. But what I have seen in the past that this is not always done. So are you actually enforcing those standards? That's really my question from an DOT perspective.
Okay, so I can take a start at it. Ming, did you want to start, or I was going to dive into our checklist.
Yeah. I think this is really based on MnDOT's decision, and certainly during our process, we always recommend different standards need to be included for certain type of communication or project or message sharing. But it also largely depends on how mature those standards are. We know that especially when we start talking about DSRC, 5G, or connected vehicle related, there are not a whole lot of mature standards out there. Lots of them are still under development. And so I think this is still yet to be seen in that particular area. But from MnDOT's perspective, I think, Rashmi, do you have any?
I think that when you think of enforcing ITS standards, now let me just kind of take you back to our decision tree and our checklist, what we have in our checklist. Well, let's get back. The decision tree offers different categories. So we have a Class A, a B1, B2, and C. And C would be covering like that connected and automated vehicle area, applications. When you think of the A, B1, and B2, we clearly identify our ITS standards within our ITS checklists. And so as far as making sure that we're within compliance, yes. I think that for what the Class C checklists offer, we have ITS standards, but it's not, we need to we are in the midst of working on updating those through our 2018 architecture. So I do think that there are going to be some unknowns there on the ITS standards, and with the architecture output and some of the set-it tools and things like that, I think that might be helpful in understanding what those standards are. I think that's a really good point, but and I think that we need to work on that. But in answer to your question, as far as enforcing ITS standards, I mean, we have that within our compliance of the ITS checklist for A, B1, and B2 checklists. We probably need to look at that CAV perspective on ITS standards a little bit more closely. Would you agree, Ming?
Even back to some other, again, the user term traditional ITS components, I think enforcing ITS standards has always been a challenge. I think MnDOT did a pretty good job in terms of enforcing certain standards for MnDOT owned systems.
Right.
And however, we have seen many times that individual agencies and individuals interpret those standards differently. Sometimes the difference can be slight, and sometimes the difference can make a total game changer. So enforcing the standards on the DOT side, and I think that's happening to some degree, but in terms of enforcing how local agencies are utilizing ITS standards, that can be a different story.
Yeah.
Okay, thank you.
And the CJSC has a comment on the checkbox. Jesse, you can unmute yourself if you have any comments.
Yeah, I'll just reiterate what's in the comment, that I definitely agree with Ming that the standards, like for the vehicles to communicate with the roadside equipment like traffic signals, they are still evolving. There are some there, but they're not perfect, they're not final, they're not all inclusive, but it's so critical to be tracking them and trying to follow them, because we're obviously going to be having to talk to vehicles that might operate in Minnesota one day and then a week later in California.
Yeah, very true.
You know, this will be critical, but yeah, they're not really solid, they're not really complete yet, but we cannot ignore them either. So it's a moving target, but we've got to track that moving target.
How do you handle tracking that moving target? Do you have any tips on that one?
We are not doing enough V2I yet that it's become an issue, but the few folks that have started doing it are trying to use the existing standards, and sometimes they work fine, and sometimes they are not standard across different manufacturers, different vendors' systems. So there are standards, and then there are options within the standards, and the options can sometimes cause interoperability problems if different vendors treat them differently. I am not an expert, but I've recently heard a couple of presentations from those who are. I think that's the gist of it, is that the standards are there, there's a framework, but there's a lot of stuff around the edges that are not really standardized, and especially between different vendors of equipment on the vehicle, or especially on the roadside. You know, traffic signal equipment, for example, and radios.
Got it.
All right. Well, go ahead.
One last comment. Say something? I'm sorry. Yeah, I'll make it very quick. So Jesse, I'm not even talking about evolving standards. I'm talking about the ones already, published as part of the National ITS Architecture. And so I'm working on a project in Florida where we actually want to go and ask basically automotive vehicle suppliers to be in compliance with the architecture. So I have to rely on somebody making, identifying the standards and then everybody adhering to it. So if it's only half-hearted and nobody really cares, then what's the point? That's really where I'm coming from. Yeah.
Good. It's a good point, and I'm not sure I know enough about what the automotive manufacturers and their suppliers are doing with regard to these standards. Most of that is done by Federal Highways Research Center, which is primarily in the Washington, D.C. area and with a couple of other sites around the country. So I think I'm over my head in commenting about that. What I have heard primarily secondhand is that there's only a few messages that are really standardized, and maybe not even really standardized. The basic safety message that you probably have heard about is one of those, and that's what they're focusing on. And again, I'm over my head in talking about what the automakers are doing. I don't work with that. I don't know the details of that, but we're in the early stages, I would say, of having a robust set of vehicle to infrastructure standards, but they are evolving, and we have to track them. Otherwise, we might be installing a lot of equipment that is not compatible with what the rest of the country is doing. So it's a challenge. It's a challenge, but it's a moving. I'd say it's a moving target, but we have to be tracking that moving target.
Agreed. Thank you.
I'll offer one other comment from one of my colleagues who knows a lot more about it than I do, and that is, especially in these areas of buying equipment that has to adhere to some standards that may not be well defined, be careful about making major hardware investments at this point, because some of the standards may change and may make those major investments unusable. So he says, citing a colleague named Ed Folk, he says this is the time to be doing small experiments to learn the technology, to learn how to use it, and better understand what the standards really mean. This is a time for doing that learning, but not for massive infrastructure hardware developments.
Good tip. Thank you.
Thank you, Jesse. And that's exactly what I'm doing right now at Metro Transit. So we'll talk. And, in the interest of time, so thank you again to Rashmi and Ming for your presentation. It triggered a lot of comments, and I'm sure for the audience, you'll be sending us to those two. And also, another interesting development of INCOSE is there is a agreement with SAE International to jointly promote systems engineering in the automotive side. So Oliver may you have an opportunity to host webinars to let us learn more about that, and then we'll sign off right here, and we'll see you in January. You will get notice from us on the next webinars, and happy holidays, everyone.
Thank you, everyone.
Thank you.
Bye. Bye-bye.
Have a wonderful holiday season. Goodbye.